Pleasant afternoon, everyone. I'm Dr. Sam Grozman, and today my talk will be focused on answering why your hospital needs a 3D printer. This lecture was supported in part by the Canuto and Pilar Borromeo Professorial Chair. And I would like to disclose that my relationship with the medical industry has not influenced this talk in any form. This is the outline of my talk, and my objectives are the following: to introduce applications of 3D printing in the hospital setting, to demonstrate applications of 3D printing before and during the COVID pandemic, and to highlight our experience. Whenever I talk on disruptive innovation, I always start with two slides. The first is that early adopters always win. I would like to reinforce to all present here today that when disruptive technology is introduced, it's always best to keep an open mind. And just because society is not ready for it, it doesn't mean that it's not needed. The second slide that I always show is from the quote of my favorite science fiction author, H.G. Wells. This has been my mantra whenever I evaluate the use of technology, and I believe that this will be applicable for industry as well. We have had 4 industrial revolutions so far. The first was when man learned to use machines for mass production, and using the power of steam, we learned to use mechanical devices to make mass production more efficient and reliable. The second part of the Industrial Revolution was organizing systems for mass production. Each step for making a product was organized in such a way that parts were added along the production line. The third Industrial Revolution focused on automated production and using programmable controls, IT and system robotics. And for now, the fourth Industrial Revolution utilizes cyber-physical systems with heavy use of machine learning and big data analysis. Essentially, this is the creation of smart factories synced by cloud networks and includes the Internet of Things. Industry 4.0 strives to break the barriers involved in regular manufacture of goods. It may be seen as the great equalizer for manufacturing, and this technology has the power to create better outcomes and equalize or level the playing field. To illustrate how Industry 4.0 changes manufacturing, imagine the way a product is created from concept to consumer. There are many steps, and the product is moved from area to area. In Industry 4.0, we may be able to skip most of the steps and make goods available faster and more reliably with customization, removing transport and storage from the equation. So what is 3D printing? 3D printing was patented by Chuck Hull in 1983. He coined the term stereolithography and therefore is the father of 3D printing. 3D printing is creating three-dimensional objects from a digital file. It is an additive manufacturing process. And an object is created with successive layers of material. This is in contrast with the traditional manufacturing process of subtractive manufacturing, where the object is formed by hollowing out a material. Additive manufacturing would have several subtypes, SLA being the classic model, and stereolithography uses light to cure resin in successive layers. In FDM, or FFF, or fused deposition modeling, this consumer-friendly form of 3D printing is used when one layer of filament is added on top of each other. Selective laser sintering is a new process that can be used for 3D printing metal as well. At present, this is the World 3D Printing Map by Fab Labs, and I'm elated to know that we are well represented. So I've introduced 3D printing and how it has the potential to change the world. How did it change yours? In 2015, I managed to buy my first 3D printer. It was like getting a pair of rose-colored glasses. That made me want to 3D print everything. How would you use this high-tech device? Well, for me, this was my first project. My oven toaster knob broke, and I still use it today. This was my first 3D application. So what are the applications of additive manufacturing in the medical field? And what does the literature say? In 2016, Tak et al. Listed the journal accounts on the use of 3D printing in medicine. And since 1999, you would see that the growth has been exponential. In 2017, Shepelev mapped the 3D medical, the use of 3D printing in the medical world. So, anyari, Pilipinas, no? The authors missed us by a few months, and we are still happy that we managed to represent our country by producing this study. 3D applications in medicine. I've divided it into two, those that directly affect our patients and those that do not. So the direct application includes patient-specific surgical models. 3D printing has been used to create patient-specific organ replicas that surgeons can use for practicing and while preparing for complicated operations. There is an increasing evidence in the world that this is slowly improving the way we operate on our patients. Medical devices and instruments. Sterile surgical instruments can be produced with the use of 3D printers. One of the main benefits is that rather than traditional manufacturing methods, the production cost decreases as well as turnaround time. Affordable prosthesis. 3D printing in the medical field can be used to produce prosthetic limbs that are customized to suit and fit the wearer. It is common for amputees to wait for weeks to months to receive prosthetics through the traditional route, and 3D printing actually makes this faster. Finally, we have bioprinting and tissue engineering. With this, we can print various biocompatible scaffolds for the generation of organs. And in this video, we see a bony scaffold made from two different biomaterials. We know the different applications for 3D printing, and let me enumerate the users per medical subspecialty. You would see that majority of these would be from orthopedic surgeons. So what do they use it for? Certainly not for toaster knobs. Mainly, it's used as a surgical guide and for some use for making implants and prosthetics. Now, I've discussed the international experience. So what is the direct applications in our own small bubble? For patient-specific models, we created and continue to create surgical models that help our patients. Our hybrid experience is unique in the world for now, and we continue to study its effects on our patients. Medical devices and instruments. When we see a need to improve products available to us, we take it. And we have the freedom to modify existing implements for proper surgery. Affordable prosthetics. Hand prosthetics are few and availability is low. We have the capacity to help our patients and collaborate with them in improving the present designs available. Of special note is the group of Enable, which is an international group that helps make a hand for other patients. And we do have some membership here in the Philippines, locally in Cebu. Finally, bioprinting and tissue engineering. For now, we don't have any experience in this, but we will soon. Given our local experience, is this all that additive manufacturing can offer? Well, there are indirect applications that help our patients as well. Direct digital manufacturing streamlines the creation of goods by decreasing the number of steps for the final production to reach consumers. Indirect application also include rapid iterative design, and the design process is a methodology on the cyclic process and prototyping. Usually, this takes time, but with additive manufacturing, we can decrease the turnaround time, for prototype making. This is an example during the COVID pandemic as to the turnaround time for the development of face shield. The idea was started in March 17, 2020, and large-scale deliveries of more than 2,000 shields per day were done in as early as 2 weeks. Finally, digital supply chains. We see the differences between traditional supply chains and additive manufacturing impacted supply chains. Basically, it carries the advantages that it is faster, it has less waste, it is cheaper, and it's hedged against disruptions of supply chains. So in summary, indirect applications as applied to the hospital setting can be summarized as rapid repairs, spare parts on demand, and rapid manufacturing. It becomes even more important in our setting when we take the local scenario into account. Presently, we have 1,800 hospitals, 60% of them are private, and we have a ratio of 1 hospital bed per 1,000 population. With these kinds of numbers, we expect that the material will be overused. All the equipment will be overused, and since our purchasing plans are not very well thought of, the equipment is often used beyond its life expectancy. Additionally, support for these devices when they break down presents some geographic challenges. 3D printing can help us overcome these challenges. Let me show you what we've done so far. So these are the 3 R's: replace, repair, and rethink. This is a 20-year-old OR light. The manufacturer does not have the sterilizable light holder available anymore. So I measured the diameter of this with my trusty caliper. I used a cheaper filament initially for my prototyping, and then subsequently selected a high temperature filament, and voila, a light holder in 3 days. Small parts like this from an X-ray reader can easily be duplicated. This will help bioengineers decrease the downtime and the cost of maintenance of machines. As consumers, we use devices and we have insight as to what needs to improve in a given product. We are limited to ideas before, but additive manufacturing can help create physical objects from our ideas. This is a PAPR that our team created with the help of 3D printing and vacuum forming. The pandemic caught us all unprepared. We felt more isolated than ever with regard to supply chain issues. As a developing country, resources were hard to get. So, what was the international 3D printing response to the pandemic? Nazir et al. Has divided into 3 major areas. The first one, 3 major areas: alternative supply source, PPEs, and hacks. My first example is the Venturi valves. It connects to the patient's face mask to deliver oxygen at a fixed concentration. The valves need to be replaced for each patient. During the height of the pandemic in Italy, there was a shortage noted for this. These clever engineers managed to reverse engineer it, and as many as 100 products were produced within 24 hours from the time of concept to delivery. COVID-19 specimen collection kits were also at a shortage in Nevada. So the University of Nevada School of Medicine tried to address this acute shortage with the use of 3D printers. PPEs. Various shapes and sizes of face masks were seen. These were often seen in Thingiverse and Yegi. And we saw some designs being implemented locally as well. Hacks. When we modify devices for off-label use, it is called a hack. And perhaps this is one of the more famous ones, wherein they used a snorkel as a respiratory mask. We also saw respirators being converted into PAPRs from scratch. So, what was my COVID response? My first project, early in the pandemic, we learned that traditional nebulization increases the risk of viral transmission to staff and other patients. A metered dose inhaler was needed for the intubated patients. And while we never used a lot of this before, suddenly the supply was lacking. I was asked to see what 3D printing can do. And within 48 hours, we had a prototype that worked. So much so that I was bombarded by emails requesting for the files, which I gave, of course. I tried to redesign the face shield also with my own innovations. Ear savers were a dime a dozen, and I considered adding institutional logos as a morale booster for the overworked frontliners. I also looked at the respirators and felt the need to make modification with the existing exhaust filters, and even tried my luck in creating no-touch tools. I looked at PAPRs and initially decided to make hose adapters so that we can readily use other hoods that were available. And finally, we created our own design of PAPR, and this was our output. In summary, I hope I've demonstrated the disruptiveness of 3D printing in the medical setting and how it fuels the fourth industrial revolution. We do know that we have a long way to go with regard to the use of this technology in medicine, but so far we see a lot of potential in these technologies that in our local setting. This is further exemplified by our favorable experience. Thank you for your attention.